Good morning all. Myself Yasodha. I am from SNS College of Engineering. Today we'll discuss about evolutes and envelopes. What is evolute and involute? Let's see and C1 are two one-to-one correspondence space curves such that tangent at any point on C is a normal to the corresponding point on C1. Then C is called evolute of C1 and C1 is called involute of C. That is, if C is evolute of C1, then C1 lies in the tangent surface of C. Tangent vectors to C and C1 are perpendicular. In this graph, red curve represents involute and blue curve represents evolute. In simple, given curve is involute. For that involute curve, we have finding the center of curvature at each point. If we joint all the centers of curvature point, we'll get an evolute of that curve. Here some of the examples are given for understanding evolutes and involute curve. Let's see the curves. First one. The daughter curve represents involute and the circle represents evolute. Next graph. Here red curve represents involute and the blue represents evolute. Next graph. Evolutes of an ellipse is given. So evolute means a curve is the locus of all its centers of curvature. That is to say that when the center of curvature of each point on a curve is drawn, the resultant shape will be the evolute of that curve. Next, we'll see the envelope. So, what is envelope? A curve which touches each member of a given family of curve is called envelope of that family. This concept is often used to find the maximum or minimum values of a function under certain constraints. Next, we'll see some example. First one, envelope of a parabola is given. Next, this plot gives the envelope of the family of lines connecting the points t, 0, 0, k minus t, in which k takes the value 1. Next, have you ever seen this? A little bright curve formed when light rays reflect off the circular walls of your cup and overlap. That curve so happens to be the curve of a cardioid and is the caustic envelope of a circle. So evolutes are the curves that represent the path traced by the point on another curve as it moves. We have discussed the evolutes. Envelopes are the curves formed by the collection of tangent lines to a family of curves. They help us analyze extremal values and critical points within the context of a parameterized family of curves. Evolutes and envelopes have a wide range of applications in calculus, from curve analysis to optimization problems, and they provide powerful insights into the behavior of functions and curves. These concepts can be applied to real world sceneries in engineering, physics, and various fields, making them not only theoretical but also practical tools for problem solving. Thank you.